Um, Great. All right, welcome, folks. This is the Kubernetes Clinic from Fairwinds. Most common misconfigurations in Kubernetes. We're going to be talking through some benchmarking that we've been doing. We'll get into where we get this information, why it's relevant, et cetera, in a few minutes. But excited to have you here. I think that the world of Kubernetes is still new and everybody's afraid they're doing it wrong. And so collecting some data across lots and lots of clusters to talk about what is standard is going to be, I think, helpful for everyone as we figure out what maturity looks like in Kubernetes. So let's go ahead and dive in. Real quick, Robert, you want to start by introducing yourself?
Yeah, my name is Robert Brennan. I'm Director of Open Source here at Fairwinds. I've been working in open source for probably about 6 or 7 years now. I've been working with Kubernetes for about 3 years, and I'm super excited to talk to you all today about some of our findings in terms of Kubernetes best practices and how organizations are doing adhering to those.
Great. And Joe?
Hey, everyone. My name is Joe Pelletier. Head up the product side of things here at Fairwinds, and my background is primarily in DevOps and security tooling, and so I'm excited today to share with you a little bit of what we're seeing across configurations in Kubernetes today. And Kendall?
Yeah, and I'm Kendall. I'm president here at Fairwinds, been involved with Fairwinds from basically the beginning. We have been a Kubernetes company for a very long time, and so watching the evolution of Kubernetes adoption go from, hey, we really need help just standing up a cluster because it's really hard and nobody cares if they're doing things right. They're just trying to do anything, all the way up to sort of where we are today, where people are starting to get to advanced security postures, making sure that configuration and networking are locked down all the way to very fine points. And even the ability for us to be able to collect data across enough organizations to talk coherently about benchmarking is, it's exciting for me because this is a significant evolution in terms of where we've been in the ecosystem. So real quick, we got this data across 100,000 workloads across hundreds of organizations. And the configurations that we're checking cover 3 categories: reliability, security, and efficiency. I think that a lot of the data that we collect, how do I say this? People are interested in all 3 categories. Security is often the most pressing category for a lot of people, but let's be honest, all 3 are very neatly tied together. So if you're running inefficient, if you're running under provisioned, and something is, it becomes an attack vector. If things are going to go down or whatever, all of that is intertwined. And so reliability is efficiency, is security. And we're going to be talking about all 3 categories today. So
yeah, and Kendall, one thing just to add to that, I think a lot of folks, when they go out to start thinking about, checking their configurations, to your point, a lot of it is thought of as a security, from a security mindset, which is great, right? Because a lot of folks understand that Kubernetes needs to, you need to intentionally make those workloads secure. But what we're finding is there's lots of different types of checks around just general reliability of how those workloads run and making sure workloads are, resource efficient, cost effective, et cetera. And I think keeping the aperture open where you're looking at all dimensions of configuration posture is really key to, running Kubernetes well. So just to tee up a little bit of sort of what we're going to be discussing today in the presentation.
Yeah. So to be clear, and we'll get a little bit into this later on, Fairwinds makes software that helps you with configuration and helps its governance, its security, its efficiency, its reliability, all of these things. And that's where this information is coming from, is the data that we've collected and anonymized from our software. And so the reason that's relevant is this is exactly what we do, is help people get this right. And as a result, we also see all the things that folks can often do wrong. And that's what we want to talk about. So I want to be clear that we're going to cover a few categories. We're going to talk about a few of the high level things, but there is way more information out there in terms of like common problems, common misconfigurations, et cetera. We're just going to touch on a couple of high priority things and go from there. So how do you compare? Let's start with reliability. And before we talk about the number of organizations missing liveness and readiness probes, Robert, talk for just a minute about why liveness and readiness probes matter.
Well, so let me actually just start by talking a little bit about how to read these graphs, just because we're going to be seeing a lot of these today. So basically what we did was we broke our every organization out into 10 different buckets. And we essentially said, okay, what percentage of organizations have a very small amount of their workloads affected by this issue? So you can see that top line for missing liveness probes. About 35% of organizations have 0 to 10% of their workloads affected, meaning they're doing a really great job. They're getting at least 90% of their workloads taken care of for having liveness probes. And then each bucket is basically another 10% of organizations, or sorry, another 10% of workloads affected. So, the next 17% of organizations have 10 to 20% of their workloads affected, or 11 to 20% of their workloads affected. And you can see all the way down to 2% of organizations have almost all of their workloads affected. So that's kind of how to read this, to see kind of where you can see the longer lines basically means there's more organizations in that bucket. So for liveness probes here, we can see most organizations are doing a good job. Very few organizations are doing a really bad job with this, but most organizations are somewhere in the middle, where they're doing this for some of their workloads and not all of them. Hopefully that all makes sense. Happy to answer any questions on how to read these graphs in the Q&A as well.
Yeah, feel free, by the way, to drop notes in the Q&A or in the chat as we go, and we'll try to answer those as we go. But yeah, Robert, talk about why it matters at all.
Cool. So liveness and readiness probes are basically a way for Kubernetes to understand whether your application is alive and ready to serve traffic. So basically, Kubernetes gives you a way to specify how to interact with your application in a way that it can tell that it's healthy. This is often an HTTP endpoint. You might define like a health Z endpoint at the root of your application that maybe checks if your database is alive and it's connected, checks if other resources are ready for it to be connected to, and then it returns a 200 if everything's okay, and it returns 500 if something's wrong. And basically, Kubernetes will use those endpoints to figure out, can I start draining traffic from the old, if you release a new deployment, it will start draining traffic from the old one and moving it to the new one. If your application is not ready, though, you don't want it to start doing that yet. So you can give Kubernetes a hint as to whether your application is ready to serve traffic using that. That would be the readiness probe. And then similarly for the liveness probe, Kubernetes will routinely just poll your application and make sure that it's still alive and still ready to serve traffic. And if it sees the liveness probe start responding incorrectly, it will pull traffic away from that pod. I think it'll also try and restart that pod to make it healthy again.
So I mean, the reason I'm asking this, Robert, is 2% of the organizations have almost none of their workloads set with liveness and readiness probes, which means that for 2%, 2 out of 100, which is a small percentage, but is still, there are organizations out there who have no idea if their applications are live and ready, right? Or at least the vast majority of their workloads, and that's a problem.
It's a serious problem, yeah. Because if something starts going wrong, Kubernetes can't self-heal. That's one of the great things about Kubernetes is that it heals itself when things go wrong. And this is a great way for you to tell Kubernetes, hey, something's going wrong. Please try to self-heal here.
Yeah, otherwise you're going to have to manually check, and you're going to have to manually fix when the whole reason you're using Kubernetes is for that automated response. So I just do want to point out, though, that this is one of those situations where the bar is pretty high. If you're not using liveness and readiness probes, to be clear, you are in a lower percentage than the average. The average company is doing pretty good. 65% of organizations are not setting liveness and readiness probes for some workloads, but the vast majority of organizations are doing it for at least some of their workloads. And you are in a very small percentage if you're not using it at all.
Yeah, and one thing to see here too is that this configuration is usually done, it looks like at the same time, right? Because if you look at the distribution of companies that are setting liveness and readiness probes, right, it's very similar, right? If they're setting a liveness probe, chances are they're also setting the readiness probe correctly at the same time. So it's possible when you're going down the path and trying to see, do I have a liveness probe enabled? Do I have a readiness probe enabled? Look for both at the same time, because this is generally the same type of configuration, or this configuration is done generally at the same time with each other.
Often it's the exact same spec.
Yep. Great point.
Right. Okay, y'all ready to move on? Let's talk about CPU limits and requests missing. So again, I'm gonna stop and ask that you define these things, Robert, as we go. So explain for folks what it means to even just set CPU requests and limits and why that matters.
Yeah. So one of the most common pieces of configuration people leave out when deploying things to Kubernetes is giving Kubernetes hints as to how much CPU or memory this workload is supposed to be using. If you don't set those things, and Kubernetes can't tell if your application is misbehaving, it can't figure out how to properly provision resources for that application. So for instance, if this application needs to have at least 2 CPUs available for it to use at any given time, because you could get a burst of traffic and you want to be able to serve that well. If you don't give Kubernetes that hint, it's possible it will pack your application in with a bunch of other applications onto the same node. And when your application tries to scale up, there won't be the right amount of CPU left for it. So you can set a CPU request to basically say, always reserve at least this much CPU for my application to use. And then you'll be guaranteed to have at least that much CPU available for you to scale up into. CPU limits are a good way to specify, above and beyond those requests, that amount that I'm always going to reserve. How much CPU can you allow this application to use? If it has the room to grow, Kubernetes will allow it to grow up to its limit, as long as it's not, you won't be guaranteed to have that room. But if that CPU is available in the node, then it will allow you to kind of scale up into it.
Yeah, great. So, Joe, spend a minute talking about this data.
Yeah, so I think one of the things that we recommend with clients is making sure that they have actually at least I think the CPU request set as part of configuring their workloads, right? And that's because you don't want to necessarily have your workloads running without Kubernetes having this clarity. And if you don't specify this and your application suddenly needs to consume lots of CPU or memory because it's doing some intensive use cases, like maybe something that's highly computational, Kubernetes is not going to be prepared to allocate that amount of resource. So we always recommend that you at least have that CPU request as well. There are different ways you can enforce this type of behavior. Not to go too off track of the topic here, but there are concepts called admission controllers that help enforce certain policies and guardrails at the time of deployment. And one of the most popular guardrails that we see our clients use is one around enforcing those CPU requests. We're going to talk about, I think, memory requests later as well. Those are very sensible guardrails to apply to a cluster that you're managing for one or many teams. And it can help you get to better compliance or get better aligned to best practices in the long term as well.
And if you don't set limits, let's say you do set requests at a minimum, but you don't set limits, and suddenly an application has I guess not a memory leak, a CPU leak. Suddenly starts to just consume an incredible amount of CPU for some reason. Kubernetes will just scale that up and scale it up and scale that up, right? And your cloud spend can be affected by that.
Yeah, usually it's worth setting. It's worth setting both. Requests are definitely the more important thing, though, to make sure that application always behaves correctly. The CPU limits, it's only going to scale up insofar as it already has room on that node that the application's already in. Yeah. So it could maybe starve another application that it also has is looking to scale beyond its requests. So setting CPU limits is definitely a good best practice. But you can see in these graphs here, organizations have specifically, they do a much better job on requests because that is a much more important setting, right? We have 50% of organizations have set this on the vast majority of workloads, versus for limits, it's more, like a third of organizations have set it for the vast majority. There's really never any reason to skip CPU requests. Your application is always going to behave better if you reserve a certain amount of CPU for it.
Yeah. Okay, so to correct what I just said there, Robert, it's not going to wildly scale and start spinning up new nodes because you didn't set CPU limits. It's only going to consume everything that's in that node, which could affect other applications. Okay, well that's important that I get those. You're like being kind to me when we should probably just get those details right. My bad. Okay, perfect. Y'all ready to go on to the next thing?
Yeah.
Okay, let's move on. Reliability. So missing memory limits and requests. So let's talk about, how is this different and how is this the same?
Yeah, it's definitely a very similar category with memory limits and requests, as opposed to CPU limits and requests. Same exact best practices apply. By giving Kubernetes hints as to what your application needs in terms of memory, it can do a much better job of scaling your application, making sure it doesn't misbehave, things like that. The big difference, I would say, is with memory limits and CPU limits. With CPU limits, as you hit your limits, Kubernetes is just going to throttle the CPU usage for your application. So it might slow down a little bit as it's can't run as many CPU instructions as it wants to, as quickly as it wants to. Whereas with memory limits, if you surpass those, Kubernetes might kill the actual pod and start a new version. So if you have a memory leak or something like that, it'll help clear out that memory leak.
Yeah.
That's really the big thing to keep in mind here.
One thing too to mention is, I know we're categorizing this under reliability because there's, first and foremost, this is a key part of ensuring your application is available for customers. But there's also a security angle to this. So there are certain types of kind of resource exhaustion attacks, similar to like denial of service attacks, where those attacks are designed to essentially try to knock over the system, right? They want to exhaust all the compute available on that system. And when you don't have limits in place, right, that's where in the cloud, you could theoretically keep scaling your compute, but you will, that also translates into cost issues, right? So I think it's important where to have obviously the requests, but also the limits in place in order to make sure that you're avoiding those types of resource exhaustion type scenarios as well. I think this is also a recent piece of guidance from the Kubernetes hardening guide released by the NSA around being able to set memory requests and limits for that particular security reason as well. So there are some scenarios where these configurations, the guidance that we're providing, first and foremost, it's about keeping your application available, but it also may have other secondary effects that are important for overall, good configuration posture.
Yeah. Okay. Great. And I think, there's a fine line here. We've got a number of these different categories, and so far we've been talking about reliability in terms of CPU requests and limits, memory requests and limits, because if those things are set incorrectly, they will affect other workloads' reliability, right? But when it comes to memory limits and requests, what we're talking about on this particular slide is those workloads that just don't even have limits set, right? Mm-hmm. But let's also be clear that there are a lot of people out there who know they should set limits, but they have no idea how to set those limits. And so, our next slide talks about these memory limits being much too high or much too low. And if you need help getting these things right, we've got things for you. But let's talk about this slide for a minute here. Joe, you want to start?
Yeah, I'll go ahead and kick it off. I think we're talking about hey, you need to configure requests and limits for CPU and memory, and that's a great piece of guidance, and you can also do enforcement on that, like we were talking about, putting guardrails in place to prevent deployments that don't have those values set. But the bigger challenge is actually understanding what should the values be. And in our experience, a lot of companies running Kubernetes, the downstream application teams, they're trying to get their application out as quick as possible. So what we find is that those teams may either provide too much memory or CPU requirements for their workloads, which ultimately leads to cost overruns, like you're either using too much capacity or you're spending too much for those workloads to run. Or the inverse is true. They may actually not know what to set, and so they set too little of a value. And so being able to measure your cluster at any given time to understand, are your workloads provisioned with too much compute or too little compute, is really important for not only a reliability of the system, but making sure you're running Kubernetes efficiently, right? It's all about kind of reducing the amount of wasted compute. And Robert, I don't know if you have any other examples of where, I know you work with Kubernetes today, like how do you go about kind of solving that problem today?
So what's interesting to note is that, if you look at this data, you can see far more organizations are setting their memory limits too high versus too low. It's much easier to, if you set things too low, you'll generally see it very quickly, right? Your application will become unstable and reliable. It'll start crashing. You'll get out of memory issues. So most organizations, you can see 70% of organizations are setting their limits too low on very few of their workloads. It's only 30% that have a reasonable number of their workloads affected by having limits too low, but around half have a good number of their workloads set too high. So it's much easier to over provision than under provision. So this is a really important thing, not just from an efficiency perspective, but really from a cost perspective. Because if you're setting them too high on each of your workloads, then you're provisioning too many nodes and you're going to have huge cost overruns. Typically what I will do is when I'm trying to get this right, try and look at graphs in some kind of application management platform to see, what's my actual memory usage and where are my requested limits set and how do those compare? Usually if you've got a good application and, I'm leading a little bit into Fairwinds Insights, our commercial application here, where you can see kind of the range of requests and limits that you're setting, as well as how your actual usage compares to those. And what we often see is that the actual usage is well below the requests and limits. And that gives you a hint that you can drop those requests and limits safely without affecting your application.
Yeah. Yeah, and it kind of goes back to the fact that the different application teams are generally the ones that have to be setting these values, and it's important to be able to give those teams very direct feedback so that they're not having to guess, right? And I think one of the things that you highlighted, Robert, is it sounds like you use Fairwinds Insights today to kind of set those values, and that's because the feedback from Insights is very direct around, based on your historical usage, here's what we recommend for requests and limits.
I think, if I'm an application developer and my whole life has been living in Ruby or Go and building a thing that I know needs to, act a certain way, what I'm not used to having to do is say, okay, I think it needs this much CPU. I think it needs, and you can guess wildly. And honestly, that's not a bad place to start. It's just you want to collect data so that you can then tweak and improve. But yeah, I think it makes sense to me that people don't know how to set that people aren't clear what that is. And so well, how much memory do I need? 8 gigs, turns out you need 1/4 of a gig. It's just not surprising that people get this wrong. In my opinion. So, okay, ready to move on?
Yep.
Let's talk about 50% of organizations have at least half of their workloads affected by a suboptimal pull policy. Robert, tell us what a suboptimal pull policy is.
Yeah, so one of the best practices in terms of making your application secure and reliable is setting your image pull policy to always. That basically tells Kubernetes that anytime it spins up a new pod for that application, the pod reaches out to your Docker repository and looks to see, what's the image I should be running and pulls that down. If you don't set that to always, Kubernetes will try to be smart about finding a cached image on the node that pod's spinning up on, which sounds like it would be a nice, efficient way to make that pod start faster, which is why that option is there. But it can lead to different versions of your application running on in different pods. It can lead to your application not actually pulling the latest version that's available, and instead using some old version that maybe have a security issue inside of it. It may not be the same image that's being used by other pods, and it just leads to all sorts of headaches from just a reliability and consistency perspective.
So just to say that back to you, Robert, we have an application running in production. We notice that there's a security vulnerability. We go and patch that security vulnerability, and as Kubernetes is spinning up new versions of the application, it should be, if it's set to always, the pull policy, pulling that new version in. But it may be that if you didn't set that, it finds a cached version that still has that security vulnerability, and it just spins that up and keeps going. So instead of our application patching itself in the most efficient way, it's getting there slowly. And that's a security patch. More likely it's you've decided to move the pixels 5, or that image 5 pixels to the left, and some of your versions are working and some of your versions aren't. and man, you want to figure out how to troubleshoot that, like when there's a cached version running and you're like, why isn't this working? And it's working for you and it's not working for him. And like, anyways, it causes problems. So that's what you're pushing for, right?
Exactly.
Okay.
Exactly.
Yeah, and Kendall, you brought up a great example. This is just yet another configuration where it can stretch, security and kind of reliability as well. So you're going to find that pattern in a lot of these different types of configurations.
Right. And so interestingly, part of our benchmarking here is we're seeing the configurations that people get wrong a lot, but the software that we're pulling this benchmarking data from is also a tool that is used to enforce policy. And so we can also see what our customers are using as common policy for enforcing correct configuration. So it's one thing to just have misconfiguration. It's another thing for us to be able to look across lots of workloads and say, what are the policies that people are using to enforce correct configuration? And I think it's interesting that 30% of organizations have made this a policy for the majority of their workloads, meaning this is probably one of the more common policies that we see, that 30% of organizations are setting this.
Yeah, and I think one of the things too with the pull policy is we're generally recommending that it's set to always, so that you're always pulling the latest image. But to your point, Kendall, there's also a scenario where you want to prevent new applications from getting into Kubernetes where it doesn't have pull policy set to always, and so there's typically admission controller policies in place that block those workloads from going in, and also at the same time give feedback to that application developer saying, by the way, you should be setting this pull policy to always, and that's usually a very quick fix in order to get the application to comply and move on into running Kubernetes. So, we're finding, you're right, we're definitely finding customers kind of deploying some of these sensible policies to start, where it's around making sure applications are configured with, minimal best practices to enable that good production readiness. And fortunately, a lot of these fixes are very straightforward too. It just requires, usually a one-line change, and that developer's off and running. And so that's kind of we're trying to make developers go faster and ship faster with a lot of our feedback from Fairwinds Insights.
Yeah. Okay, we got to keep moving because we've got a bunch more to get through here. So I want to make sure we get through on time. Let's talk about the security bits. Insecure capabilities. Almost a quarter of organizations have 91 to 100% of their workloads running with insecure capabilities. Let's talk about what an insecure capability is, Robert.
Yeah, so when you spin up a Docker container inside your Kubernetes cluster, like we've been talking about, there's a lot of configuration you supply to Kubernetes to tell it kind of how to run that container. It's things like how much CPU and memory to use. One of those things that you can supply to Kubernetes is what capabilities to give that container. Basically, what is it allowed to do on the host node, on the underlying infrastructure. And there are some capabilities that are enabled by default. There's some capabilities that are dropped by default, and you can basically mix and match those capabilities based on what permissions your container needs. Most of the time, nobody needs any of those capabilities. So this is one of those things where the default configuration isn't necessarily the most secure configuration. So it's important to if you really want a good security posture, to think through what capabilities, if any, does my application really need. And if it doesn't need the capabilities that are included by default, make sure to drop those.
So you're saying my default security posture should not just be to set everything to run as root all the time.
Exactly. Yeah.
Okay.
Yeah. And it's kind of interesting to see sort of the bimodal nature of this, right? There's definitely some organizations that are, very aware of this, right? We might have some bias in our data because they are using Fairwinds Insights in order to, ensure their workloads are secure. But there's also companies out there that aren't aware of, like Robert said, Kubernetes is sort of insecure by default, right? And that they have to make these intentional decisions around how they configure workloads. So, fortunately, I think a lot of these fixes, like the previous examples, are fairly straightforward. And it's really about providing that feedback to the engineer who's responsible for deploying the app as quickly as possible and as effectively as possible. And I think that's how you drive change and drive more security around Kubernetes workloads.
Yeah, well, so talk about how privilege escalation, this next slide, is different from insecure capabilities like we were just talking about.
It's a very similar concept. It pairs with some other Kubernetes security context type settings. it's again something that's enabled by default that you're allowed to escalate privileges, but disabling privilege escalation is a good way to make sure that things stay as tamped down from a security perspective as possible, and that an attacker would not be able to escape this container and get at other things in that host node. Again, I think, like I said, this is something that's not turned on by default. So like Joe pointed out before, you still see this bimodal nature where some organizations have clearly made a point of turning this off for the vast majority of their workloads, which don't need it, maybe by using a policy or admission control, things like that. Whereas some organizations seem to be completely unaware that this is something they should be doing, and have not set it for the vast majority of their workloads.
Yeah, I think it's interesting that gap there in the middle where it's like we're completely unaware of the problem, we're aware of the problem, and we maybe haven't applied it everywhere. It's interesting there. And I was making a joke about running as root, but we actually have a separate slide for that. So 70% of organizations are running 11% or more of their workloads with root access. Were you going to say something, Joe?
Yeah, I was just gonna say, I mean, a lot of these examples do fall under the sort of the security context of the Kubernetes workload. And so that's why you're seeing there's actually multiple scenarios where you can, over permission your your applications, and that, can expose you to additional risk, right? And I think run as root is actually one of the most common examples of those. A lot of times, if your application does not need root access, this is an excellent configuration to go ahead and fix, because it helps, again, limit the blast radius of a potential attack, right? If you don't want, attackers being able to get access to the root and then be able to, do other, kind of launch additional attacks off of that. So I think this is a very similar to the previous slides in terms of the number of different types of examples of where, security is important, and yet it's, organizations are trying to gain visibility so that they can apply these changes.
Yeah. And likewise, image vulnerability. And this is an interesting graph because 60% are running images with vulnerabilities in production, which means 40% have basically figured out how to remove those almost entirely, which is another, to me, it sounds like you have a whole bunch of organizations who are trying to use new and updated software, and then you have a few organizations that know to actually proactively check to avoid image vulnerability. Would that be an accurate assumption probably around what's going on here, do y'all think?
Yeah, it's a tricky thing, making sure that you're not running vulnerable images, because there's new vulnerabilities getting announced all the time. So it's something you really have to keep up with, right? It's not just a matter of installing the latest and greatest. It's a matter of proactively scanning on an ongoing basis all the things that are inside your cluster to make sure that any new vulnerabilities that get announced get cross-checked against the images that you're running, so that you know when you need to update.
Yeah, and this is going to be constantly a moving target. I think getting to zero is definitely, to some extent, that's not the first goal. I think the goal here is being able to be able to gain visibility and constantly identify the highest risk packages to be upgrading, or the highest risk image layers to be upgrading as well. So that's really the goal here. And a lot of organizations, I think, until recently, haven't had great solutions for gaining this their existing image vulnerability exposure. And the integration points for gaining this exposure are really meant as early as the CI stage when you're building that container, all the way through to in the actual running Kubernetes cluster, making sure that you can understand what's my image vulnerability exposure right now for the the running environment. So it's important to gain visibility kind of in both areas, one for the feedback loop to developers, and the other one for being able to manage risk.
Great. Let's talk about how outdated Helm charts and deprecated APIs relate. I mean, this is different from known security vulnerabilities or image vulnerabilities, but the two can be tied together in some ways. But these graphs are kind of shocking, especially the API version deprecated one is this huge line in terms of most organizations seem to have figured that one out. Maybe because when an API breaks, you notice. But I mean, yeah, Robert, talk about outdated Helm charts, deprecated APIs, why they matter, and staying on top of it.
Yeah, so keeping your Helm chart up to date is important to make sure you're getting in any bug fixes that are being released, any security patches that are being released, and to make sure that you have access to the latest and greatest features. A lot of times, old versions go out of support very quickly, so it's important to stay kind of up to date on those. You can see a good number of organizations, over a third have really prioritized, making sure that those Helm charts are up to date. But a lot of people are at least a few versions behind on something. So it's again, kind of a moving target because there's new releases getting made all the time. But again, it's important to kind of keep an eye on, how far behind are you? Are there security patches that have been released that you should be pulling in, things like that?
Yeah, these usually these types of issues usually come up when a SRE team or platform engineering team is trying to do upgrades, right? They need to first make sure that they're not using any deprecated API versions that might be problematic in the next upgrade, and that they're using sort of the latest Helm charts as well. I think being able to stay on top of this type of data becomes increasingly important when you're running multiple clusters in an organization, right? That's where you need to be able to gain some amount of centralized visibility so that you can properly plan those upgrades. And I think you're going to see different levels of compliance, if you will, around these issues, depending on how many clusters an organization has running.
Yeah, I think, one thing I want to mention too, so we're going to dive in now into Fairwinds Insights. We're going to show you the software that we're getting this benchmarking data from, and how organizations that are using Insights are avoiding these common mistakes. But I do want to go back to Joe's comment about bias in the data. The kinds of organizations that we are collecting this data from are the kinds of organizations who have said, we are aware that there are misconfigurations, security problems, reliability problems, and we want to address them in a proactive way, which means that all of our data is already biased towards the people who are going to take the right action towards this. So our data is probably incredibly optimistic because some huge percentage of organizations out there are clueless to these issues. And the places that we're collecting this data from are the people who are specifically tuned into it. So if you want to be one of those organizations, let's show you what Fairwinds Insights looks like and how you can use this software to avoid these problems. So I'm not going to do a very in-depth demo, but I just want to show you real quick. When you log into Fairwinds Insights, we're going to give you a dashboard with an overview of your organization. This organization has 2 clusters running. You can see the history of how those clusters have changed over time in just a quick trend bar there. We also give your organization an overall health score and show you the top issues across your organization right here. So if you have 50 clusters running, you're going to see, hey, image pull policy should be set to always. This is one we just talked about, right? But you can click into either of these clusters, and it will take you to a dashboard that's going to show when action items were introduced to the cluster. It'll give you an overall health score for that cluster. We also have some cost analysis here. But let's show you a little bit in the action items. So here's a cluster with a whole bunch of different things going on. These are all the issues that Fairwinds Insights is checking for, that we're collecting benchmarking data around and saying these are the common things. So you see image has vulnerabilities, containers should not have dangerous privileges. These are all things that we were just talking about, right? So these are security issues. You can also sort by reliability, efficiency. You can kick those things out to someone, assign it to someone. You can create a ticket, kick that out to your ticketing system. There's a whole bunch more here. And I want to show you where we're collecting all this information from. So Polaris is an open source tool of ours that checks for common misconfigurations. We've been running Kubernetes for a long time across lots of different organizations. We know what people get wrong. But we also have some of our other open source in here. Nova's checking for those out-of-date Helm charts, Pluto checking for those deprecated APIs. Goldilocks is our tool that we use, and Expose and Insights to help you get those resource requests and limits just right, because that's difficult. We saw how many organizations were struggling with that. Trivy checks for container vulnerabilities. We also have Kubebench, Kubehunter, Kubesec, and support for OPA, so you can write your own custom policy with the Open Policy Agent. I'm not going to show you everything here, but I do want to show that when it comes to enforcing that policy, here's one of the ways a lot of organizations are doing that in the CI/CD pipeline. So here we have an engineer named Robert who happens to be on this call, pushing a container as root, adding in secure permissions to the container. And you can see that Circle CI is failing this or passing this, but Fairwinds Insights is failing it. So this is how the average engineer is going to interact with this. You're going to set policy that to meet the standards that your organization needs to meet. Your average engineer is going to go through here, say, hey, what did I do wrong? Click on this button. It's going to load them into the UI and say, hey, you have given this container privileged access that it does not need, right? The kinds of things that we were just talking about that the average engineer might not have any idea about. We're going to expose those things, show somebody not just what's wrong, but how to go about fixing it so that you can improve your security posture over time. Now we have a whole bunch of policy, automation, ways to look at the different vulnerabilities that are running in the cluster. There's lots and lots here in Fairwinds Insights. If you want to know more, give us a call. Let us know you're interested. We're happy to set up a demo for you. We even have a free trial. So a lot of people, you set up a free trial and run this on a cluster for even a couple of weeks, you're going to learn a tremendous amount about all the things you're doing right or wrong. So you can look at benchmarks all day and go back and see if you can apply them, or you can spend 5 minutes installing a tool, our software product that's going to help expose all of this for you. So that's Fairwinds Insights. Again, there's a lot more there. I'm not going to go deep into that right now. But we know that cloud native organizations care about security, cost optimization, and including policy and guardrails. If you're here attending this webinar, these are probably things that matter to you. Fairwinds Insights is our software that makes those things easy. Everyone is moving to Kubernetes. It has become the default. Everyone is afraid they're going to do it wrong. What if you had software that told you what you're doing wrong and helped you do it right? So that's exactly what we've created. That's why Fairwinds Insights exists, both in terms of just exposing what's out there, as well as helping you get it right in the future. So finally, we do have more detail in this benchmark report. So you can go to these 2 bit.ly links if you're interested. Kate's benchmark, or you can get a demo of our software at that link. But that's where we are. Thanks for being with us today. And does anyone have any questions? We can stay on for a few minutes if you do. I haven't seen any questions come through. Sometimes people ask all the questions and sometimes we don't get anything. But if any of you have questions, we'll hang out in a minute. Otherwise, we'll wrap up. But I'll leave this up on the screen for a minute in case you want to type in one of those links. Anything I missed, Robert, Joe, that you want to say in conclusion?
No, I think that was a great overview. I think, like you mentioned, like a lot of this data, all this data has come from our software, which is pulling together multiple tools around security, cost, efficiency, reliability. I think our approach at this is not only helping organizations surface up the data, but also being able to take action and ultimately get applications to ship faster, right? So we're really all about kind of enabling speed, enabling applications to get to market quicker, but doing it in a way that aligns with security as well as reliability and efficiency. So yeah, we're definitely interested in feedback and anyone who's interested in a trial of getting a glimpse of what types of issues may exist in their environment.
Yeah, and I see there's a participant with their hand up. If you can type your question into chat or the Q&A, that's the way to go about that. And we did have just now a question come in. We get so many image vulnerabilities. How do we identify the important ones? Does Fairwinds help to identify? Hey, what if we could prioritize? Talk about that, Robert.
Yeah, so each vulnerability gets rated on a scale provided by NIST with 5 categories, basically from critical down to low. And so Insights picks up that data and we'll basically look for, out of all the vulnerabilities that are in this image, what is the highest category of severity, and it makes that the level of severity for that image. So you can see in Insights here, there are mainly criticals and highs that Insights has found. There could potentially be mediums and lows as well.
Yeah, there's one low on here, but yeah, we're prioritizing those for you on those container vulnerabilities.
Exactly.
Yeah, and so one thing is around like the container images that you're self-managing, right? We do provide visibility into the specific packages and the CVEs around those packages. We do also provide sort of the criticality of that CVE as well. So that's useful for weighing how important is this package to be updating now versus, planning for later. The other thing that we've noticed, though, is a lot of organizations will leverage third-party images in their environment, popular open source that's required to run the core of Kubernetes. And in those cases, being able to keep track of if there's a newer Helm chart available can be one easy way to just take in the new Helm chart and hopefully be able to upgrade to a version of that application that might have fewer vulnerabilities as well. Because a lot of those third-party projects are also keeping track of the vulnerabilities in their projects, and upgrading is just one action that you could take as a Kubernetes administrator.
Yep. And I want to hang out one more minute because the person who raised their hand has not yet typed something in. So we'll see if that comes through. But thanks for the question. Anyone else? Okay, well, I guess we'll wrap up. And if you decide, I don't know if you're struggling with the system, if Zoom's making it complicated, but feel free to reach out to us via email. You should have Dave's email address, and he will also be following up with a link to the recording for this. So feel free to respond to that and ask a question if you have one. We're happy to get in touch and get back to you on that. But thanks, folks, for attending our webinar on Kubernetes benchmarks. We hope this was enlightening and helpful. And if you decide you want to improve on these things that so many organizations are struggling with, reach out to us. That's why Fairwinds exists. Thanks so much. Have a great day.
Thank you.